Here we have a question. In this question, we have to find the value of equivalent force and the value of equivalent couple moment acting at speed about point O. First of all, as the given data we can see F1 is purely in downward direction, the value is 300 Newton, and F2 force is in horizontal direction, the value is 200 Newton. And F3 is given in the vector form as it's given is minus 200 I cap plus 500 J cap minus 300 K cap. Now, first of all, in order to find the moment of resultant force, we must know the moment of component of forces. For that, we'll use the value of position vectors, where R1 would be the position vector of force F1 at which force F1 is acting, R2 would be the position vector of force F2 at which force F2 is acting, R3 would be the position vector of point 3 at which force F3 is acting. As we found the value of resultant vector, just simply the cross product of vector, the position vector and the force vector would give us the moment of that vector about point O. As we can see here, this is the moment due to force F2, this is the moment due to force F3. Now, simply adding the moment, we will find the value of resultant moment about point O. So let's see what is the given. As we discussed earlier, first of all, we'll find the position vector of point R1. We'll name it as xi cap plus yj cap plus zk cap, where x, y and z would be the coordinates of the point about which force F1 is acting. Now, same as for R2 and same as for R3. We have the position vectors. Now we'll find the vector form of forces. For the force F1, we can write it as minus 300 K cap Newton, and for vector F2, we can write it as 200 J cap Newton. Now let's move forward. As it's given the value of force F3, already it's given in the vector form, we will name it as equation number 6. Now the summation of forces will give us the resultant force. From here we can write F1 plus F2 plus F3 equal to resultant force Fr. As we discussed earlier, the resultant moment due to force Fr will be equal to the moment due to the component of forces F1, F2 and F3. As you can see, we'll name it as equation number 8. Now we have the forces, we have the position vectors. Let's substitute the values and find the resultant force, and also we'll find the value of resultant moment. As you can see, the position vector R1 can be written as 2.0 J cap. The position vector R2 can be written as 1.5 I cap plus 3.5 J cap meter. Position vector R3 can be written as 1.5 I cap plus 2.03 J cap. Now let's add all forces in order to find the resultant force. That comes out to be F1 plus F2 plus F3. That comes out to be minus 200 I cap plus 700 J cap minus 600 K cap. We have the resultant force, we have the component of forces, and we have the position vector of forces at which they are acting. Now let's take the moment of each force about their position vectors about point O. We can write it as given. From here, solving the determinant, we can find the resultant moment about point O comes out to be minus 1200 I cap 450 J cap plus 1.5 1450 K cap Newton meter. Thus, we have found the value of resultant force as minus 200 I cap plus 700 J cap minus 600 K cap Newton, and the value of resultant moment as minus 1200 I cap plus 450 J cap plus 1450 K cap Newton meter. Thank you.